Okay, good morning, everybody. Thanks for joining us today. I'm delighted to be joined by Sean Hobday, so an IoT specialist from Cisco, who we've been working with actually on several IoT projects, and who is here to help us provide valuable insights into the world of IoT, the possibilities, and also some of the challenges regarding cybersecurity. So this webinar is the latest in the Supercharged program, a key theme of which is digital transformation, which brings us directly onto today's webinar topic, which is probably one of the first things that comes to mind when you think of digitization or digital transformation, and that's the Internet of Things. So the Internet of Things, or IoT, connects previously unconnected devices to the Internet, and with it, businesses can add a whole new level of digital intelligence to these devices that would otherwise remain static. But just because you can connect a device, should you? Well, only if you can extract kind of meaning from that data. And with IoT, the benefits come in when you utilize that data with analytics, with artificial intelligence and machine learning. And when implemented correctly, IoT offers endless possibilities, really. And this is a development that's simply exploding, particularly within the manufacturing sector, where connecting production machines can be made much faster and more efficient. So this is all great, but brings us back to another key theme of the Supercharged program, which is cybersecurity. So with more connected devices, put simply, you're exposing the network to more points of entry and more risk. Yet many IoT devices haven't considered security beforehand. So from a risk perspective, this is huge. And in addition to that, IoT crosses traditional gaps between IT and operations, which in itself creates new challenges in ways of working. But I'm going to pass you over to Sean to talk in more detail about this, who's the expert. So, if you have any questions, please just type them into the Q&A box on the screen. We'll make sure these are answered at the end, and there'll also be time for a Q&A session at the end. So, without further ado, I'll pass you over to Sean.
Yeah, good morning, Cisco, and look after industrial IoT or IoT. I've been doing this role, partner-facing role, for the best part of three to 4 years now. And my main focus obviously is kind of manufacturing is our main focus, I suppose, but obviously we also work across smart building environments and into healthcare and a few other verticals as well, but yeah, manufacturing is the main focus, I suppose, for myself. Can you see my screen, Richard?
Yep, all clear.
Good. So I suppose the first thing I wanted to cover off was, Cisco has been in this market for some time, or IoT market for some time. We have a portfolio that's fairly extensive. If you're not familiar with the portfolio at all, but obviously that covers from the industrial Ethernet switching range right through to things like LoRaWAN gateways and LoRaWAN capability, and obviously Wi-Fi within the industrial sector, through to software-based applications that we sell that bring the whole lot together. Software is a big focus for Cisco. But also underlying all this portfolio is our security platforms and software that we need to deliver to customers to make sure they're secure in the first place. And we've been designing solutions in this space for some time. So if you look at manufacturing, for example, I suppose we have Cisco validated designs that cover off the manufacturing space mainly, I suppose, but also automotive, food and beverage, transportation as well. So those Cisco validated designs have been around for the best part of 8 or 9 years at Cisco, I suppose, and we've obviously updated those on a regular basis. The main area of focus we've updated those CVDs with, or Cisco validated designs with, is security. So security is a big part of the design, and we want to make sure that that's documented and tested. So those Cisco validated designs are tested over in our San Jose campus, where we take the whole design solution, we validate it with all the components and obviously all the security components as well, and then we document it and update our website, and I can show you where that is in a minute. So I suppose just to reiterate, this is not new. We've been doing this for some time. You may have just not come across Cisco so much in this space. So just to kind of highlight a couple of things as we start off. One of the things that's interesting, obviously enough, is that we'll talk about ransomware, but this is a recent attack that happened actually in March this year, where Norsk Hydro, a Norwegian aluminium smelting company, were hit by a ransomware attack. You may be aware of this, I'm not sure, but I just thought it'd be interesting to start off the conversation. But they're one of the largest global aluminium manufacturers. They have fairly large smeltering operations in quite a few countries, and they got taken down by a fairly nasty attack that happened, say, in March. And effectively they had to shut the smeltering plants down. This is the type of information they had to post on the doors into the entrance of the plant, obviously to disconnect everything from their devices from the network because of this ransomware attack. So it's a fairly large operation, and obviously from a cost perspective, I could then show you in this another on the insurance business site. They obviously then had to publish their latest Q1 results or the issues they had, and obviously from a Norwegian perspective, the cost was 350 to 450 million costs as far, and that actually worked out as about 40 to 50 million pounds, I think it was. If I did a quick calculation on that, and obviously they have insurance through AIG with cyber policy, but obviously from a cost perspective, they've actually had to push back their results even further because of the situation. So just to give you an idea of the kind of costs and issues that our customers are facing if they don't look at this in a proper way. And using our architectures that we have, we can obviously hopefully prevent most of this type of attack in the first place. So I just want to cover that off, and then I'll just put this in full screen if you can then see it. So so from a segmentation point of view within industrial security, what we see is that manufacturing is the largest segmentation or segment that is covered as far as growing targets of ransomware attacks, manufacturing then being healthcare after that. So this is obviously a fairly, not a recent report, but it's pretty much the same today. It hasn't changed much, in fact. So I suppose if you're in that manufacturing segment, then obviously it's an area that you need to focus more on than previously have done. I think operational technology areas, OT areas within our manufacturing base are now actually stepping up and doing and changing things and moving forward with security. So from an impact point of view, just to highlight the costs of obviously hopefully remember Petcher and not Petcher attacks that happened back about 2 years ago now. This is mainly a Microsoft attack, but things like Merck's suffered huge losses, for example. And I know that the White House were saying after those sort of attacks in the States as well, there was a cost of around $10 billion. So significant costs that we're seeing on a regular basis, and it just highlights the situation we're currently in. So from a industrial security point of view, I think this is an area that we need to focus on more. We also need to work together with the likes of Axonex to try and implement solutions and software to start bringing visibility of what's happening on your network, whether in the OT space, in the operational technology world, I suppose, from the shop floor right through to the top floor. But vulnerabilities in automation control systems, you can see they rose by 2,400% up to 2015. So significant vulnerabilities are there probably today. And obviously, if we look at industrial Ethernet, that's a huge growth in this space. So 96% in the last 3 years. So it's a huge area that we need to focus on. Obviously, providing connectivity is key as long as it's secure in the first place. So this gives you an idea of what a Cisco validated design architecture would look like. You've got on the left-hand side, the IT part of the business, the cloud integration, the software IT systems that exist in an IT world and enterprise space. Then you've got down through to the industrial DMZ in the middle there, and then further down, obviously, into the cells levels 0 to 5, for example. That DMZ would be an industrial DMZ, and we would obviously, this is the type of solution we'd recommend to start off with. We're not suggesting you go and do this straight away, but obviously it's a step-by-step approach. And then the cell segmentation in the operational technology world in the shop floor would be either ring topologies or star topologies, depending on the design to start off with. And in there, obviously, we have controllers, we have PLCs. To provide the connectivity, and that's a typical design that we'd recommend, providing a secure path through the IT part of the business into the OT part of the business. But the challenge we see mainly in this space is the responsibility, and who takes responsibility for this network, whether it's the OT and IT working together. But our recommendation, if you've not seen this type of thing, is that we follow what's called the Purgy model. Hopefully some people on the call would have heard of the Purgy model. It's a recommendation around security around ISA 95 and IEC 62443. And this is the standard we work to with all our designs. And you'll see obviously you've got levels 0 to 3 in the factory shop floor environment. There are obviously different sensors and IoT and sensory capability that's being deployed. We then lay on some software and hardware in that space, and then obviously we got the IDMZ or DMZ, where we're putting mainly an industrial firewall potentially there, or an ASA IT-based firewall, and then you've got your enterprise levels 4 to 5. Levels with the IT part of the business, but as I say, I'll show you in a minute at the end of the call. But we obviously follow this Purgy model pretty closely, and it's key to providing a secure environment in the industrial space. So, as I mentioned, organizational boundaries and responsibilities is the key to getting a successful implementation. So who's responsible for the cell levels, and then obviously you've got the IT part of business in the red on the left-hand side, and then it's kind of the blue areas that we need to work together. So OT and IT working together is the key in glue that's going to make this work. So that's where we want to be moving forward, I suppose, or today even. So when the questionnaires go out around where does security sit and whose role is it and who has responsibility for it, you've got the OT teams on the left-hand side there, that wholly own it with the IT group. You've got a mixture of IT and OT, and obviously some people in this questionnaire were unclear about whose responsibility is it, and that's what we need to try and overcome, trying to get that responsibility between both teams or working together as both teams. But it's a key area to focus on, I suppose, and that's where we kind of start the conversation. So if a manufacturer is looking at challenges from an IT/OT dependency point of view, you've got obviously enterprise IT there in the white, centralized IT. You've got potentially plants environments, so obviously manufacturing plants, 2 or 3 or maybe even less than that, with OT personnel in that environment. It could be the plant managers. But what we see just generally is that if a plant manager in plant 1, for example, wants to request downtime or areas to some downtime in a particular plant, they request that through IT. That downtime may be given in 2 or 3 weeks' time. So the time frame potentially for that downtime and scheduling it can be some time out. So things take longer to implement because of the requirement on or having dependency on the IT part of the business. So what we do with our solutions and software is that we give the dependency back to the plant, to the plant manager, because he can use the software that we provide to actually change things, at the end of the day, for example, or the weekend, without the requirement for involving IT to a point. So that's where we see the barriers, and we overcome that sort of that barrier by implementing software like Industrial Network Director, IND, Cisco IND, Industrial Network Director, to provide that capability to the plant manager. So I was in a meeting with a customer a couple of months ago, up in Scotland, and I asked the plant manager, what are your current issues? What would be your main concern today, for example? And his response was visibility. He used the word visibility. He understood what was happening. The IT team understood what was happening on their enterprise assets, because they could see the phones, the laptops. They understood that. But they had no visibility of what was happening on the shop floor environment between their PLCs, their IOs, and their controllers. So, having visibility was his main concern. So if we could provide that first step approach to providing visibility, would be a key number one thing that would overcome his reluctance to then implement security, because unless he had visibility, he didn't know what to secure in the first place. So those industrial assets, what is that PLC talking to? Is it talking to that other IO, or HMI interfaces, for example? So once you have that visibility, we can start to then move forward and say, okay, well, this is talking to that. This is normal behavior. This is abnormal behavior. So Industrial Network Director, or Cisco Industrial Network Director, would give you that visibility in the first place. So it would build a topology view of your network and show you what is sitting behind those switches. So if you had a Cisco switch there, you could see those controllers, those IOs, those PLCs, and it would tell you what they were and what versions of software they were running and all that type of stuff, and what flows of traffic was going on. So visibility is the key thing that we see is number one situation where we go into customers. So this is just highlighting that visibility is fine, and then the other thing, I suppose, is automation. So once you've got a secure environment, you can then start to automate various processes. So you can say, well, this machine builder needs to get access to his machine at 7 o'clock tonight, for example, between 7 and 10 o'clock tonight. We can give that automation process to the plant manager. He can right-click on that switch and that PLC, and then create a secure remote VPN access into that PLC between 7 o'clock and 10 o'clock tonight. And that is an automated process for what we deploy with the software and hardware dependencies going on. So we automate this and make it secure, as obviously beforehand. So the use cases for what I'm going to talk about in a minute, and the software and hardware that we kind of put together, gives you three areas of use case. One is cell segmentation. So what that means, if you're not too IT familiar with what that really means, is that cell segmentation is if you imagine you've got three lines, as in line 1, line 2, line 3. And you can create those lines into cells. So you can create a cell so that cell 1 and cell 2 can talk to each other, but not to cell 3, for example, or cell 1 can talk to cell 3, but not to cell 2. That cell segmentation is key. So if you heard of VLANs before, virtual LANs, we can do that sort of stuff, and have done some time. But that is a fairly manual process. But we can automate that process using things like secure group tags. Secure group tags, effectively, so that the yellow tag and the green tag can talk to each other, but not to the red tag, for example. So it's a much easier way of creating flows and communication, but dividing the network up in a very simple manner. So that's cell segmentation. The next use case is remote access. So kind of as I mentioned, one of the key areas we see, or issues we kind of come across, is that a lot of the lines will have different machine builders. They're making a particular widget. That machine that machine builder will want to get access potentially to that machine, over that month, for example, or every week, normally every month, for example, to pull information about and adjust various things on that particular machine remotely. And we can implement on-demand remote access fairly simply and give that responsibility to the plant manager. So that's the second point or use case. And the third use case is what's called flow-based anomaly detection. Effectively, what we're providing here is the ability to see what is normal versus what is abnormal. Normalizing, understanding what is happening on the network and knowing what is normal is the first step in that approach. And then obviously then understanding what is abnormal and obviously blocking that automatically is where we want to get to. So those are the three use cases for this type of solution. So what does this really what does it look like? So to meet those three use cases, the first thing that we recommend, and Axonex can come in and deploy Industrial Network Director, IND, that yellow icon on the left-hand side there is a bit of software platform that gives you that visibility on the left-hand side. So it gives you access to create a topology view of your OT network, and it supports like 5 or 6 different protocols. So Modbus, SIP, Profinet, BACnet, OPC UA, for example. So those sort of protocols that we see in an OT world, it supports all those, for example. So you can start to build a topology view of your network. And then what we then do is we then use the Industrial Network Director to provide context information to a thing called Identity Services Engine, the blue icon in the middle there. And that's an IT platform. It's not an OT platform, so it's not, you need an IT operations personnel to look after the Identity Services Engine, and that would sit in Industrial DMZ, the IDMZ that I showed in that original slide, talking about the layout of the design. So context is provided from Industrial Network Director to Identity Services Engine. Identity Services Engine is a policy-based application that creates policy and behavior, so that, for example, if Sean Hobday walks into the onto the Cisco network and he's got the right antivirus software installed, and we know exactly where he's allowed to go and where he's not allowed to go based on his policy and what's assigned to him. That's a policy-based behavior solution, and that's what Identity Services Engine provides. But it also provides that in the industrial world as well. It has industrial fingerprints, for example, to support all the industrial protocols, and it has out-of-the-box fingerprinting. But what that effectively does is that ISC will provide information from IND. We can then set up these secure group tags with our Cisco industrial switches. And it's an automated process. So secure group tags, providing a tagging information about, the yellow tag can't talk to the red tag, but it can talk to the green tag in our industrial Ethernet switches. And then the kind of last thing the second use case, was on-demand remote access. So we provide a next generation firewall there to provide the firewall capability to provide tagging through to, for that machine builder, for example, to get access to that machine on that plant floor. And the third use case was looking at anomaly detection. So using NetFlow information from our Cisco switches, we provide that to a bit of software called StealthWatch that then look at what is normal versus abnormal. So those three use cases I've talked about, and that's the kind of software and hardware dependencies that provide this solution. And I'll show you the Cisco design that covers this in detail. So before I go on, Richard, is there any kind of questions you want to kind of cover to start off with on that kind of what I've covered so far?
No, not from my side. But if anyone else has a question, please feel free to ask.
Okay. Okay, I'll carry on then. So to kind of give a bit more detail around visibility and what is ISC, Identity Services Engine. So effectively, what we can see is that in this slide, there's an Industrial Network Director. You've got asset inventory on the left-hand side here that we can see coming out of IND about the switch information, what's connected to. But ISE, in combination with Industrial Network Director, you can start to see a lot more information around IoT vendor, the product, the serial number, the device type. So there's a lot more information we can then glean about what is happening behind that switch. So it's there's obviously custom attributes that we can put in there as well. So it's a much more the visualization you get, visibility you get with that combination of IND and ISE together really brings the kind of the visibility to life. As I mentioned, with IoT is not just an IT-based product, although it sits in it's a function of IT, and its responsibility would be with IT. Out of the box, there's a lot more device fingerprints that we've released with the latest versions. So you can look at building automation information, you can industrial manufacturing information that's provided with the fingerprints. Obviously, there's HVAC integration, and obviously Windows is a key area of focus around not Petcher and Petcher attacks that we've had in the past. So a lot of obviously manufacturing plants still use Windows operating systems on their PLCs, well, some of their HMI interfaces, for example. So using ISE to start fingerprinting some of this stuff is quite useful. And then one of the other areas I talked about is the policy-based solution around behavior versus abnormal versus normal. So StealthWatch is a bit of software that, again, we sell within the security portfolio that gives you that visibility. So, what is visible in the network? Who is it? What is it? Where are my devices located? And obviously, if it is compromised, we need to do something about it. So, we can start to look at relationships between the things, those IoT sensors, for example, so what's talking to what. We can start to look at rogue people, rogue participants, rogue devices that come off the network. What does normal communication look like? So that's all the type of things that we can do with StealthWatch. So it's a very nice sophisticated application that you can put on the network to see what is normal versus abnormal to start off with. So just to kind of cover a bit more detail around the segmentation, the cell segmentation perspective, we've got on the left-hand side here, we've got Industrial Network Director. You can see a small topology view that you'd see, and you can see that we've created a cell 1, for example, and you can see the devices sitting behind that switch, for example. And what we're doing effectively is using attributes to send to Identity Services Engine to create those secure group tags, those SGTs, as it says on the right-hand side. Sorry. So we can then say, what is cell 1 has secure group tag, and it's a yellow tag, for example, and all those yellow tags that fly around the network can only talk to the green tags, for example, because that might be cell 2, for example. Cell 2 might be the yellow tag. So cell 1 and cell 2 can communicate, but cell 3, which is the red tag, can't talk to each other. So just wanted to visualize that for yourselves. So this I just build a slide, but effectively, this gives you a visualization. Here you've got cell 1 and cell 2. You've got Industrial Network Director sending information to ISE, and effectively you can see that you've got the orange, blue, and green tags. And you can see that secure group tag 100 cannot talk to secure group tag 200, which is effectively cell 2. So cell 1 and cell 2, in fact, in this case, cannot communicate, but they can communicate to secure group tag 33, which is maybe the MES system, so the manufacturing execution system, MES system, they can talk to, but not between the different cells. So it's a very simple way to segment your network. And so this can all be done by the OT user. That OT user there can provide this context from within Industrial Network Director. So the next use case, just to build the slide again, is that we're effectively saying that on-demand remote access, we can see that in this case we want to get we've got a machine builder, an OEM, for example, that's going to use Cisco AnyConnect to using one of our ASA firewalls in the IDNZ, can then run an RDP session down to the PLC in cell 2. And what happens effectively is that the plant manager can right-click on that switch port on cell 2 within his topology view and create a window to obviously allow that OEM into the network using an AnyConnect VPN connection to that ASA firewall, and they create a secure group tag 777 in this case. So again, a secure group tag is created, and only that tag is used to get to that cell 2, and it can't be used anywhere else. So as you can see, it's blocked on cell 1. And then the last one, just to kind of highlight, is the flow-based anomaly detection. So the ability to obviously in this case we're seeing that there's a port scan going on. So effectively, what happens here is that that camera in cell 2 for some reason starts doing a port scan on cell 1 on that PLC down there. That is obviously not normal. So StealthWatch has already obviously normalized the traffic. It already understands what is normal versus abnormal. And that's already been set up. But the net flow information from the Cisco switch tells StealthWatch effectively that they need to and send that information to ISC. ISC then says we need to quarantine that switch port. So it sends a quarantine message effectively to the switch port as per the flow there. You can see that we block that camera from making any more communication with cell 1, and that's obviously done very, very quickly. So then they can actually investigate afterwards why that happened. Obviously, whether it's a malware issue or it could be something else, obviously. But that's an area. If for example, Norsk Hydro had StealthWatch, for example, running, they may have not have had this problem in the first place. So that kind of covers off the. I think there's a lot more I can talk about, but I just wanted to give you a flavour, of what we can provide, to start off with. And we obviously have design guides, and Richard will share this slide deck with yourselves, I'm sure. But obviously you can go in to look at these Cisco validated designs that we have with manufacturing and our converged plant-wide Ethernet CPW designs, for example, with the manufacturing. So what I'll quickly do is I'll show you where you can find this information. So if I go www.cisco.com/go/CVD. So go/CVD on cisco.com. So Cisco Validate Design. That will take you into what's called the design zone in Cisco. So we obviously have design guides for many, many different areas, but from a industrial IoT or IoT perspective, you want to scroll down to the bottom here, and what you'll see is the all industry guides. So if you click on all industry guides, it will take you into this area and the CVDs which I talked about. We've got reference features and design guides for industrial automation distribution, so utilities sector, remote and mobile assets, which we can cover separately on maybe on another event, is an area of focus for us for our machines and machine information that comes off an asset. We can start to look at the data. So Richard talked about data and being able to understand data. So we have a Kinetic platform, Cisco Kinetic software platform that can kind of pull the data from our gateways and from those machines, and then start to understand what that data is and whether that might need to be maybe sent to Microsoft Azure or another platform. But if you go down here, you'll see the industry solution guides and architecture guides, but we've got cities and communities, distribution automation, the utility sector, but then we've got the manufacturing design guides and whether that's a converged part with Ethernet. If you've got Siemens Profinet running in the network, which obviously you may have, then obviously we can support that as well. We have design guides. Our Cisco Industrial Ethernet switches support Profinet version 3. We also support Mitsubishi as well with the CC Link stuff. We also have things like connected machines. Then we've got oil and gas, remote and mobile assets, which is quite a good one to look at, transportation, etc. There's lots of information here, but one I'd like to highlight, I think, out of all these, just so you can see it, is what I've talked about today. So if you look at network and security in industrial automation environments, that will take you to this page. So this network and security industrial automation environments design guide and implementation guide is one I'd recommend to look at. And obviously, it kind of talks about the executive summary here, Industry 4.0, talks about overall equipment effectiveness, OEE, customer objectives and challenges, some of the barriers and requirements, and it goes into quite a lot of high-level detail to start off with, which is probably quite useful for some people to look at. And then some of the applications and different areas around the different vertical sectors, wastewater, mining, oil and gas, substation, utility, and the manufacturing. And then obviously it goes down into all that detail. But it talks about the purging model, which I talked about in the earlier slides, around 62443 and ISO 95. And there are obviously other areas around here, but if it covers a lot of the stuff I've already mentioned, but if you kind of carry on to it, all the security pieces here, all the bits I've talked about, if you look at, in here you'll find Industrial Network Director covered and various other bits, so IND, go/IND for if you might like more information about Industrial Network Director, deploying your switches, and then obviously it takes you around a lot of information that you can start to look at. I mean, sort of fairly interesting document to look at if you're kind of starting off looking at this, and obviously the Cisco switches, and then some of the information around asset inventories within Industrial Net Director, topology views that you can look at within Industrial Net Director, configuring secure group tags. I talked about secure group tags and tagging, and then some deployments, PX Grid and Identity Services Engine integration. Within Industrial Network Director, and then obviously there's a lot more information here, but it's just kind of highlighting to you ways that you can start to look at this, and obviously this would be something that Axonex can help you with. They can come in and deploy Industrial Network Director with you, or you can actually just pull it off cisco.com and try it yourselves. It's a free license to start off with. It's free to use. You can create a topology view, but then obviously if you want to start managing those switches, you then need to pay a license for it. So yeah, that's just kind of one area of focus that I thought would be useful. So I think with that, we'll probably stop there. I'll stop there and ask Richard if there are any questions.
Thanks, Sean. Yeah, so we'll just take the time now to open up the floor to questions. Please feel free to ask them or to type them into the Q&A box. I've got a couple here, Sean. So first one, how would you get started with industrial security? So what would be the next step?
Yeah. So I think that as I mentioned, I think I'd suggest that the customer deploys Industrial Network Director. And whether that's themselves deploying it, it just runs on a Windows platform. It's very simple to install. Axonex can help you obviously with that if you need them to come and help you with that. And let's say you can download it off cisco.com with go/IND Industrial Network Director. There you'll find the software you can pull down. As I say, if you want to start managing the Cisco switches that you've got on the network. They also support the Stratix product as well, the Rockwell Stratix, which is an OEM from Cisco as well. If you've got Rockwell Stratix products in your portfolio, in your network, then you can do it as well. But my recommendation would be put IND on the network, and obviously if you've got Identity Services Engine as well already, potentially you may have deployed that already with Axonex, then that's even better.
Brilliant. Okay. So, I mean, unless there's any more questions, after this webinar, I will send around the slides to you, along with some of the documents that Sean's just taken us through and some of those links as well. If you'd like to learn more, just get in contact with Axonex, speak to your account director. We can, as mentioned, run a demo of some of the solutions through dCloud. So happy to talk to you further about that. So I'd just like to, I suppose, wrap the webinar up now. And I'd like to take the opportunity to thank Sean for running through all that. That was brilliant. And to thank everyone as well for attending and taking the time today. Just to keep you updated on the Supercharged program, so we're running some more webinars. The next one is actually on Tuesday, which is a new era of networking, and we'll be talking all around software-defined networks. And then on the 11th of June, we'll be talking through the journey to the cloud, hybrid cloud applications, and on the 13th of June, creating the future workspace. We have Andy Williams from Cisco to talk to us about what's happening in the collaboration space. So I think that's everything now, and we'll wrap this up. So thanks to everyone and have a fantastic day.